All right, we're back with more writing. We're at 3 pages and 25% of the fourth page. Oh no, like 30. Nah, 25% because references don't count. So we're getting there, 4 pages, and let's keep writing. Push for the writing because the deadline's coming close. Thanks for watching, or thanks for stopping by. Thanks for watching on YouTube. Don't forget to follow, sub, you know the drill. All right, so we were left at adding a research-friendly CLI where we talked about Omega Conf, Hydra, to add a fully featured CLI for 3 user-facing applications, data generation, blah, blah, blah. The resulting developer experience, the final developer is research-friendly and consists of a click-to-run pipeline. Okay. As shown by the 3 sequential commands. Okay, so we want to show some bash thing. Oh my god, please tell me this listing thing has bash. I'm gonna have to ask Gemini. Can you give me a bash language tool? Or does it have it? Or can we just use plain something? Oh, come on. We're not doing my bash. I can't afford my bash. I can't afford it. Let's use plain. I don't want to argue. Yes, exactly, Gemini. Okay, so let's see if bash works. What the heck? Did I not copy? Come on. All right, so language bash caption is stuff. What is it called? Label lst bash devx. Okay, so now I can say enlisting lst bash devx. Boom. So what are the commands I actually run? Well, they're very simple. Generate data and write it to files. Notably, we also parameterize all file input, output to fully specified paths augmented by robust post-init verification in each app. If an input file does not exist, an error, a verbose error, is raised to the researcher. Compared, this is miles ahead. Nah, I don't want to use. Okay, so what is UV run group Siona -m MIMO.cdl save file path to data.h5. Okay. File. Train on generated. Train on CDL channel data. Group torch -m MIMO.train data file path to data save model dir and save model to risks. Save dir path to model. Okay. Generate synthetic data using a pre-trained model. Oh my god, am I doing the right thing here? Let's see how this looks. How does it look? Oh my god, it looks really bad. I guess I have to do this thingy here where I... I don't like default bash because the comments are italic and fonts too large. Anything clean and more compact can be another language too. There's no way we're using this. You're insane. Wait, using language SH is cleaner. Let's try this. Does this look cleaner? My ass looks cleaner. Jesus Christ, this looks so ugly. Come on. I'm not putting this in the paper. Comments are now upright and clean. Do I have to put this though? I'm gonna use this, but if it nukes the compile, I'm in big trouble though. Baramono. Oh, okay, I do like this. Oh my god, it does look nice. It does look nice. Break lines true. Can I not have this shit though? Yes. Okay, this looks... Okay, it looks more human for sure. All right. So where was I? Generate data artifact MIMO train. I need these parameters now. Space. I guess we'll do it this way. Yeah, we'll do it this way. So now how do I MIMO sample model dir path to model path to results. Okay. To the developer with fixed instructions. Okay, we have an example of bash. Wow. We only have half a page left. Okay, finally, we make full use of Python's optional but strongly recommended static type checking system. by adding formatting and by adding pre-commit hooks for automatic formatting and type hinting and type checking. This forces developers to annotate, to type annotate every, including ourselves, every Python functionality and implement robust runtime checks whenever needed to guard against invalid values. We use rough for automatic formatting and based pyrite, a fork why do I use based? For extensive type checking, an interesting challenge we had to overcome was combining pre-commit hooks with UV's mutually exclusive dependency groups, because only a single state of the virtual Python environment exists on disk at a given time. We resorted to using local pre-commit hooks that each run under UV run group name to properly type check Siona and PyTorch. The Siona and PyTorch parts of the code base. All right, so we have to start we gotta find a title for the paper too. Oh my god, I can't believe we're getting so close. It's actually happening. Yeah, there's code in here, there's dependency groups. Why does text TT look so ugly now? Holy. Ay, 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 ay. This is fine, I like it, but it seems to also affect all instances of text TT. Can I actually have it not do that? Oh my god. Because we use font to pitch URL, it starts bleeding into your electric to make like the rest of the document. Replace your previous LST set. Set default as. So I put style. Jesus Christ, man. Like, am I supposed to use the Baramono thing? I'm gonna run out of compilations. No, I did not run out of compilation time. But I still mess with... Dude, are you messing with me? Wait, maybe he wants me to use... But why am I messing with the TT? Oh, no, I didn't. Oh my god, it worked. This is what I want. Okay, can I, like, not skip above and caption? Like, what is this shit? I don't want to skip above the caption. Oh, come on, man. Okay, this is kind of good. Okay, I kind of like it. Let me see how this reads. Oh, sorry, I was reading this. Okay, we're getting there. I like how it looks. Now, we gotta write the caption for this stuff thing. The complete sequence of commands to run the full research pipeline from scratch. Sequence of bash commands. No, the sequence of multi-platform commands. This works on any platform that runs the full research pipeline in a deterministic seeded way. Finally. We also add seeding to all modules. Random seeding. All right. Oh shit, I have to cite rough now. Oh my god. Okay, come on, rough. Rough. How do I cite rough? I just do this thing here. So rough Astral Inc. Good one, because they got bought by OpenAI. All right, rough. What is it called? Extremely fast, blah blah blah, written in Rust. Very good. Linter and code formatter written in Rust. Okay. And the other one we have to cite is based pyrite, I guess. Okay. So we go based pyrite X. I don't know. We'll call it based pyrite. And we shall call it I'll call it this, a fork of pyrite. Pylance features and more. All right. Oh shit. So now we have to go into main and cite rough and based pyrite. Okay. Can I escape these UV run group? Does it work like that? I believe it does. No, it does not. Like, I can't type double dash? Okay, so I can't do this? Dude, this is wild. Oh my god. How do I type a double dash inside text TT? Helpfully converts to hyphens. Why, I have to put it in curlies. Minus. Okay, thank you. All right, dash dash. Chuk chuk chuk. Chuk 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 chuk. Is this also converted? No, this should not be, right? Because it's a yeah, these are fine. Okay, well, I think this is it. We don't have any more room in the paper. We wrote the full paper to validate the NCS model architecture, blah, blah, blah. Let's cite ourselves. We gotta cite ourselves because we say, well, let's write the intro. Okay. Where the heck is the intro? Here it is. Legacy research code is often a significant pain point, despite certain pain reproducibility with many popular repositories from the 2017, 22, 21 period still being used today, despite still used as they are today, despite their tooling being out of date. This is even more true for Python, where dependency management was hell was a well known issue at the time. Despite these short... So can we find the citation for this? So let me check. Oh my god, if I can find some sort of news that says Python dependency hell. There's a shit ton of work. Oh my god. This is hilarious. This is hilarious. Like, this is actually a problem. Wowee. I'm so happy I found this now. All right, so dependency hell being a well-acknowledged issue at the time. It was a well-acknowledged and studied issue at the time. So we got to cite this guy and more. Oh my god. This is hilarious. Another one. Give me one more. Yeah, there's like smart pip, all this shit. Like, this is wild. I'm so happy I found this now. Smart pip. Okay, I'm going crazy. All right, so this is even more. This is even true. This is clear. This is definitely the case. This is the case for Python, where dependency was well acknowledged at the time. Fortunately, ever since, modern frameworks like UV have largely solved these issues. Our goal in this short paper is to present our systematic approach to modernizing such a repository. In particular, we target the repository at cite, ours, anon, I'm gonna have to anonymize ours, and its associated publication. I'm gonna call ourselves high impact. It's just publication. Okay, cite our paper anon. Okay, so I have to cite ourselves now. So score. We have to cite ourselves. So first, let's cite ourselves. Boom. Okay. Now we have to be careful. We need to anonymize this because we're gonna get disk rejected. Okay, so we'll put ourselves. How do I comment this? What? I have to manually. Oh, okay. Here we go. All right. So anonymous. 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 Yeah, let's anonymize ourselves. There we go. So this becomes our paper anon. Well, it can be our paper. We don't need this thing because we can just swap it then, right? So, boom. This is the repository is an application of score-based generative models in wireless multi-input, multiple input, multiple output, MIMO, channel estimation. We picked this particular application area and repository because the source code, because it covers 3 aspects that are still very relevant today. And they are generating scientific training data using scientific software, scientific simulation, non-deep learning software, training a score-based diffusion generative model, generating synthetic data using a pre-trained score-based generative model in high precision domains where hyperparameters are sensitive. In scientific domains are sensitive to numerical variations. I gotta cite our repo too. So for that, we shall do this. Anonymous. So anonymous URL anonymous. Why do I have errors? Oh, for God's sake, man. I can't use the article. Hey, thanks for stopping by. I'm wrapping up writing a paper, which I'm going to submit to a conference That's pretty much what's happening because I worked on code. And I got to write a 4-page paper. It's actually pretty interesting because the paper is about what I streamed for the last month, which is if you look at my YouTube channel, there's a giant ass series about reproducing one of the papers from my PhD with generative models and all that stuff. So I went through all of that, dealt with a lot of issues, and now I found this reproducibility conference, and I basically spent today writing about that experience in about 4 pages. And that's where we are right now. So let's see, where was I? Oh my god, why is the citation busted? Oh, repeated entry, article or paper. Oh, this is easy to fix then. Is it? Very confusing. So we're our paper. It's only one. Yeah, check out my YouTube channel if you feel like it, but if not, it's fine. I wouldn't worry about it. Just messing around, finishing this paper. What the heck? There's 23 errors. Oh, I guess the citation is broken now. Missing number treated as 0. So what does it want from me here? Does it need like a year? Well, I'm just gonna put anonymous too. Okay, we're past that. No more stupid errors. So we're just gonna anonymize ourselves for the submission because we can't reference. Okay. Come on, where was I? Fortunately, ever since, modern frameworks like UV have largely solved these issues and enabled much more seamless dependency management. Non-deep learning software, training a score-based diffusion generative model. It's fine, I wouldn't worry about it. It's like... just feel free to ask anything, but I gotta finish writing this. If you read this paper, it's not that bad. Because I didn't really learn anything new from the series. We just struggled to sort of reproduce the work I did 4 years ago, which was pretty bad, to be honest. Like, it took a lot of time. All right, so I gotta finish the conclusion. So what the heck did we do here? Ah, shit, and I have to find this. Let's put this 120. I'll guesstimate it. Check later. Why do I still have so many? Okay, this is fine. So I need to drag this to a new page. So I only have 4 pages for this paper. And I'm actually running out of space. Okay. This is all the space we have. Okay, which is a lot actually. I have enough space now. So, write the conclusion. What the heck did we do? Let me think here. We have room for some little math here. Nah, hang on. So what is the conclusion? So I gotta write about the YouTube series in the paper too, which is also pretty hilarious to write about. Modernizing the legacy code base took approximately 40 hours and was all recorded planned and will be released as a multi-episode YouTube series. Okay, the most difficult part was reproducing the sampling algorithm because of its high sensitivity to numerical parameters and the misdirection in the original code base, which deviated from the associated paper. Okay, because we had a lot of trouble with this shit. I wrote something in the paper, but then the code was not doing that. Okay, what else did we learn? Anything else interesting? Additionally, we were not able to overcome the fundamental gap between Siona and MATLAB simulations of the CDL channel family, despite matching as many parameters as possible and even trying some variations. To the best of our However, despite these differences, training a score-based generative model was successful. The synthetic data resembles the new training data closer. Oh yeah, it is a weird one, right? Try to guess. I don't know. I'm US based right now. I'm on the West Coast. Yeah, it is Eastern EU. Yeah, originally. Yeah, you're right. But I've been in the US for a while now, for almost 10 years. However, despite these differences, training a score-based model was all says synthetic data resembles the new training data closer than the original code base did. Future work should continue investigating other downstream applications of the retrained. Should continue. Future work could continue the modernization and reproducibility of other downstream applications of the retrained generative model. In particular, MIMO channel estimation using conditional sampling, as in the original paper. We're gonna have to cite us here. Despite these differences, training score was successful. No, it is Eastern Europe. No, you are right. I won't tell the exact country, but you are right. Okay, what the heck do I need to do here? So we're not able to overcome the fundamental gap. The numerical this is due to the legacy code base. This is because of no longer having access to a MATLAB license, which makes a case which reinforces the case for an open source package like Siona. Man, this is kind of a strong claim to make. I'm gonna shit on MATLAB now. Despite these differences, training score and the modernization was very successful. Future work it is now also trivial to change another improvement that it was already done and not discussed in the paper was that we were easily able to add support for using neural network architectures from the popular diffusers library, finally breaking away from the NCSN v2 architecture. This enables future work to research better architectures and hyperparameters for downstream applications of score-based generative models, in particular MIMO channel estimation as in the original paper. All right, so we have to cite diffusers now. What the heck do I have to do here? I do have to cite diffusers. Ah, shit. And I have to write an abstract. Oh God, what is this? Diffusers library. State-of-the-art diffusion models for video. Is there a citation? There is a citation. Oh my God. Okay. What else do we need to do? Diffusers.